Today, I'm going to be doing a physics lab from General Science. It's actually Exploring Creation with Physics, 2nd edition. The supplies are safety goggles, a stopwatch, a pile of books between 6 and 9 centimeters thick. These are at exactly 6 centimeters. A wooden board that's about a meter long. Mine is exactly 3 feet. It's actually a piece of shelf. It's smooth, it's finished wood. And a pencil that I made a mark with, which I actually used electrical tape so that my high-speed camera over here in the back can actually capture it and see where the center mark is, so we have an exact measurement instead of doing it with a stopwatch, which is what it suggests. I didn't like the stopwatch idea, so I grabbed my high-speed camera, and the last is a tennis ball, which I stole from my dog, which is why my door is locked right now. Alright. The procedure is you take the smooth side of the board, which I have already done, put it up, marked it in the center at exactly 18 inches with a piece of electrical tape that's black. You prop the board up at one end, which I've done before I started videotaping, so I didn't look stupid trying to get a board and everything set up while on camera. I made the mark, measured. You record the distance in proper precision. Seeing as the board is exactly 3 feet, it's exactly 18 inches on each side. I measured blah blah blah, it's in metric, but it's exactly 3 feet, so it's very easy to convert. You set up your experiment, you've done both measurements, hold the ball at the very top of the board and be ready to release it. The exact moment you release said such ball, start the stopwatch. Stop the stopwatch when the ball hits the mark. Write down the time that you've measured. Be as precise as possible, which we don't need to do because of the high-speed camera, which will be capturing at 240 frames per second. I won't have to use a stopwatch, and it says to repeat this 5 times so you can average it out and get rid of any errors. I don't have to do that, so when I release, the high-speed camera is going to capture it all, telling me exactly how long it took from point A to point B, from point B to point C, and from point A to C, which it says to do. So you go from the top of the board, the time measurement from the top of the board to the middle, then the time measurement from the middle to the end, and the total time that it took for the entire thing, which will all be captured via high speed. Once you do that, you divide, you do the math that it says here, you average it, because you would be taking multiple measurements. This is all skipped. You average the results on the total again. Save the supplies. You'll use them again in the next experiment. Okay. The purpose of this is to measure velocity by gravity, because it's going to take time to speed up from point A at the top of the board to the middle of the board. It's going to be accelerating. It's still going to be accelerating when it hits the end of the board, but it's going to pick up speed between point A and point B, and from point B to point C it's going to pick up even more speed. So we're going to calculate out the speed differences and the time that it takes to travel the total distance to measure velocity and I forget the other thing that we're measuring. Velocity, and let's flip backward to see what the other thing was. Velocity and displacement. That was the other thing, is displacement. Without any further ado, let's do the experiment. I'm going to turn on my camera. Back here. It has a very tight field of view, so it has to be way back. So it's real narrow. Turn it on. There we go. It's focused. I'm going to start the recording. And 3, 2, 1, released. And that should be good. I'm going to play it back real quick. Now we've recorded our high-speed footage of it traveling. I observed that it did not follow the same path each time, which was bothering me. And the last time I did it, it actually rolled off of the board, which hopefully isn't a problem. I have enough footage, hopefully, that I can get a good set of runs out of it. I should have said my hypothesis before. My hypothesis is that it will take less time to travel the second half of the distance than the first half, and that if you average it, that should be an average, that it... Honestly, I have no idea other than the fact that the ball will travel from one end of the board to the other because of gravity. That's going to take a different amount of time for each half. So my hypothesis is that it'll take a different amount of time to travel from the top of the board to the middle, and from the middle of the board to the bottom. The result is... It traveled from the top to the bottom of the board. I will have to put the slow motion footage in here somewhere and say the exact number of frames and time that it took from the top to the middle to the bottom, and total distance. Conclusion is, the ball rolled down the board, and that it took me almost an hour to set up camera 1 in front of me, camera 2 over here to the side, camera 3, the high speed over here on top of my brother's telescope, and the light, which you can probably see reflecting off my hand and stuff. This was that stage light, which I will put a link to the video right here. You can watch that. It's how I made the stage light. If anyone wishes to do it, feel free. Thank you for watching. Hopefully you enjoyed the experiment 1.1 of physics, exploring creation with physics, 2nd edition.